Hello everyone, I'm Huang a student from Beihang University. I'm honored to have the opportunity to share my work with you today. Texer used to be an automatic conversion tool from LaTeX art journal to a web format. That was the original idea of the Texer, and Abhishek has done a great job on that. He created this package during 2022 and 2023. And here I would like to show you a published art journal article generated via Texer. So this is an article using Texer to convert from LaTeX to the HTML format. You can see everything works well, including footnotes, references, and citation, and so on. To go deeper with this idea, he proposed to enhance Texer by supporting the conversion from Sweave to R Markdown. It will be a great help because many of the early R packages use the Sweave to write vignettes, which will be shown to users as a PDF format on CRAN. However, as time goes on, R Markdown, a lightweight markup language, has begun to gradually replace Swift and better present content on CRAN in the form of HTML. In order to help many RPack developers who haven't used R Markdown or don't have enough time to do the format conversion manually to migrate from Swift to R Markdown, Texer aims to help people automate this conversion process. That is most of my work in Texer. Texer is dedicated to solving some key points in the process of Swift to Markdown conversion, so that users will have the convenience of automated conversion as much as possible. There is a list of challenges that is hard to accomplish through automation. To provide a robust solution, Texer does not only use some simple replacement logic based on regular expressions and use pandoc to convert the rest part of the article, which may cause some problems. You can see a field example of the conversion from Swift to Markdown using pandoc in the red column. It cannot convert the items to native Markdown syntax, and obviously, the output is not what we expected. Here I will introduce the highlights of Texer's new features. Most importantly, Texer can automatically convert R code chunks from Swift to Markdown. It can also provide various options for YAML front matter, which is very useful for users to customize the output. We also provide 3 default templates: Bookdown, Bulk Style, and Lightdown for users to choose from. Our goal is to try to keep the LaTeX style as much as possible, rather than just converting through mapping. We embedded CSS and JavaScript in the output HTML file header via YAML front matter to make the output more LaTeX-like. To ease the integration of the references, Texer can automatically integrate the references from the Sweave file into citation file as BibTeX format, and then use the bibliography in the YAML front matter. We also keep the cross-references dynamical in the output R Markdown file, which make it easier for users to add or delete numbered items like figures, tables, and sections, anywhere without manually edit other numbering. We noticed that some users may have their own LaTeX macros defined in the Sweave file, so we also support user-defined LaTeX macros in Texer. Texer can automatically detect them and convert to available syntax in the output Markdown file. For developers, I guess you may be interested in the technical details of the Texer. So next, I will share some of them with you. The first is the core function of Texer, the conversion of ARCO chunks. We have a four-step process to convert the ARCO chunks from Sweave to Markdown. First, we detect the ARCO chunks in the Sweave file. Second, we extract the code chunks apart from the article. Third, we convert the article to Markdown. Finally, we insert the ARCO chunks into the Markdown file. To make it easier to understand, I put the workflow with sample code in the red column. You can see how Texer converts ARCO chunks from Sweave to Markdown. But why can't we use Lua filter throughout the whole process? As you may not heard of Lua filter, I will give it a brief introduction. Lua filter is a powerful tool in Pandoc, which can be used to modify the abstract syntax tree of the document. Lua filter can be used to modify the document in a more flexible way than the built-in functions in Pandoc. So let's go back to the problem. That is because the abstract syntax tree, or we call AST in Pandoc, is not complicated enough to record the attributes of ARCO chunks. It could tell which part is an ARCO chunk, but it cannot preserve the label, the figure options, and other attributes of the ARCO chunk. So we have to extract the ARCO chunks apart from the article so that it won't be converted by Pandoc. In the middle of the process, we address the position with a placeholder, which is a unique string that can be easily replaced by the old ARCO chunk later. Another technical detail I want to share you is the automatic numbering of the figures. We know that in Sweave or LaTeX, user can manually set the numbering of figures, or automatically it's optional. But in most of the time, users may want to keep the numbering dynamic to make it easier to edit later. So we have to find a way to automatically number the figures in the output or Markdown file. What makes it more complicated than Markdown is that there are code chunks in R Markdown which can output figures, and the figures from R code chunks are automatically numbered excluding those outside the code chunk. Although it makes numbering figures more difficult, it also inspires us. Why can't we embed all figures as code chunks in the R Markdown? In that way, we can use our Markdown's feature to number all the figures. It has three advantages. First, all figures can be automatically numbered without the need for users to manually number them. Second, all the figures can be dynamically referenced, so you don't need to change the reference number when inserting or deleting them. Finally, figures in code chunks are centered, which is more like LaTeX style, whereas Markdown's default style are left aligned. In terms of implementation, we use Pandoc's Lua filter to capture figures objects in the AST and then convert them into to corresponding code chunks based on their priorities. Then I want to show you how we make effort to keep the LaTeX style in the output or Markdown file. As we know, YAML formatter can control part of the article style. However, it has many limitations. For example, sections and equations can only be styled the same way at the same time, and there is no way to make them both alike LaTeX style just via YAML formatter. Therefore, we embedded CSS and JavaScript in the output HTML file header to achieve our goal. These three images show the results of our work. On the left is the original file HTML file, and in the center is the HTML file with the header added, and the red one is the PDF generated by Sweave. As you can see, by adding header, we have made the style of math equations and sections in the HTML file closer to the LaTeX style. As with LaTeX, the font size of the first level section is smaller than the title, and the numbering of the equations is independent of the section number. This makes it easier for users to convert Sweave to Markdown without worrying about style changes. The last I want to show you is a simple web article generated by Texer. As you can see, here is the source code, and here is the converted Markdown file. The last is the article convert from Markdown. As you can see, the article is well structured and the style is similar to LaTeX. The numbering of the figures and the equations are automatically generated. The code chunks are well preserved and can be well executed in rendering. Considering the time limit, I cannot show you the whole process of the conversion here, but later I will show you another one. You can also try it yourself by using the Texer package. You can find the source code of the example article in the Texer repository. I hope you can enjoy the conversion process and the final result. At last, I'm going to talk about the future goals of Texer. Firstly, I'm glad to announce that Texer has been released to version 1.5.0. In this version, we have added new key features and fixed some bugs. Some of them have been mentioned before. In the future, we plan to provide small options for users to customize the article style. For example, we may add more templates for users to choose from, or provide options for users to customize the numbering style. And we will keep collecting feedbacks from users and improve the conversion quality. We hope to make Texer a more user-friendly and a more powerful tool for users to convert Sweave to Markdown. Most of the time, I benefit from the open source community. Thanks to Google Summer of Code, I have a good chance to contribute to the community and share my work with others. I'm honored to have the opportunity. That's all of my presentation. If you have any questions or suggestions, please feel free to contact me. You can scan the QR code here to visit the slide of this presentation on GitHub. You can also find my contact information in my profile. I'm looking forward to your feedback. Thank you for your listening. Here I will show you how to use Texture to convert a Sweave article to a Markdown, and then I will render it to HTML to show the final result. This is the article we want to convert today. So you can see here, we use rnw to rmd function in Texture. It had only one required parameter, which is the path of the input Sweave file. Other optional parameters like output, format, autonumber sections. You can read the document to get more detail about them. This time, we set output format as Markdown and the autonumber section as true. Okay, it generated our Markdown file efficiently. Let's check it. Yes, that is. You can see the conversion is perfect. And then we knit it to HTML. You can see. It's very easy to use. That's all the workflow of the conversion.